The Intel Platform Management Interface, or IPMI, is an interface that allows for the management and monitoring of systems within a computer, including the CPU, the firmware, and the operating system. And this interface exists independently from all of these other components. In addition to its monitoring capabilities, IPMI also gives ways to interact with these various systems. Some examples of how you can interact using IPMI include allowing you to interact and manage a computer that is powered off or frozen, and giving you the ability to install operating systems onto a system remotely. These two examples alone illustrate the critical nature of IPMI and just how powerful it can be within a system. As such, it's a natural target for attackers because if an attacker can gain the ability to control a system even when it's powered off, or start to interact with low-level components like the CPU, firmware, or install remote operating systems, then the attacker has an immense amount of control over a system. There are a lot of benefits provided to a system by IPMI. One such benefit is IPMI's ability to monitor system health. And what this means is that IPMI can have an idea of when something is about to fail and start to give warning before that failure actually happens. And this gives system administrators or computer maintainers the ability to fix that failure before it becomes a problem. It's a universal standard, which means that almost all hardware vendors support IPMI, and that gives a little bit more reliance in that you can trust that IPMI will most likely be supported by whatever system you're using. And in terms of other low-level interfaces, IPMI has relatively simple configuration changes, so it's not an overly complex system to use. A component of IPMI is the Baseboard Management Controller, or BMC, and this is what allows the platform to monitor the physical state of the system. And the key part of this monitoring is that the BMC does its monitoring through an independent connection. So that's how it allows for remote monitoring even when a system is powered off, and to not be reliant on the other components within the system. Unfortunately, like any other piece of hardware or software, there are vulnerabilities or the potential for vulnerabilities to be introduced by something like IPMI. One such vulnerability is called the Cipher0 vulnerability, and this vulnerability has the potential to allow full access to the BMC. The way this works is by making use of Cipher0 within the IPMI cipher suite. So IPMI ships with 15 different cipher suites, and they're numbered starting from 0. So Cipher0 is the first cipher suite. And this vulnerability lies in the fact that Cipher0 does not require authentication to access the BMC through it. Now, these ciphers can be turned on or off, but oftentimes Cipher0 is enabled by default, and users don't modify the configuration to turn Cipher0 off. So any BMC that has Cipher0 turned on is potentially vulnerable to an attacker connecting to that BMC, and then once they have control of the BMC or a connection to the BMC, they can start to manipulate very low-level settings like kernel settings or the actual firmware on the system. And that has the potential to inflict a huge amount of damage on a system. Now, even with IPMI modules that require authentication, there is a vulnerability associated with that, and that's within the IPMI 2.0 RAKP authentication module. The way this works is that attackers can submit password guesses in the form of salted password hashes before authentication occurs. IPMI 2.0 RAKP will then subsequently return a salted hash to an attacker. This attacker can then take that salted hash and try to start cracking that hash offline. Once they successfully crack that hash, they will be able to submit the value they obtain as authentication and successfully authenticate to the IPMI once again gaining full control over the system.